are geckos in my house. Whenever I go, they are always around, and they are called squamates. Squamates are a group, or well, I can say a squad of reptiles including lizard, snake, and amphisbaenian. They are incredibly diverse with thousands of species that have evolved to survive in a various environment. Some of them slither on the ground, crawls on the walls, you probably know it already, swimming across the ocean, and even gliding over the tree roof. Woo, that's Draco, super cool, isn't it? But then, since I moved to the UK, I couldn't find them anywhere. My mission to find lizard in the UK brings me to discover not only the modern lizard, but also the ancient lizard, the ancestor of all the squad, the ancient squamates.
I don't think that there are any snakes in the Britain, for example. Only few kinds of lizards and only just few of them.
My curiosity leads me to meet Dr. Mateus.
My name is Mateusz Tałanda. I am a paleontologist working at the University of Warsaw in Poland.
Recently, Mateus published a finding about Belartia lizard fossil that was found in the Isle of Skye. Belartia shed light on the evolution process that happened to squamate during the mid-Jurassic era, which was around 167 million years ago and lasted until the mid-Cretaceous. They are the origin of the modern squamate that we usually see, and also shared the world they're living with the dinosaurs. What a legend! However, why were the dinosaurs got extinct but squamate keeps evolving until today is still a mystery.
We know only about two groups of lizards that went extinct. These are big marine mosasaurs and less known but also relatively large Polyglyphanodon. These were the only two big lizard groups that extinct, probably together with dinosaurs. But Belartia will help us understand which Mesozoic lizards belong to modern groups and which Mesozoic lizards belong to extinct groups.
The first discovery of Belartia in 1998 was only a few single bones that even mixed together with other remains. It then made researchers find it really hard to examine. Since most of the squamates fossils are super fragile and scattered everywhere, their evolutions remain unclear. But not until this nearly complete Belartia skeleton was discovered. With a total of 10 cm long, the smallest bone of Belartia has only about 1/5 of a millimeter. What a well-preserved super tiny fossil they just found! Thanks to technology, now researchers doesn't have to damage their fossils with a needle to separate the skeleton and rock anymore.
Only after the first tomography we realized that there's a whole skeleton inside. So that was a surprise. The rock that entombs Belartia is very small. It's like about this size. So it was really easy to put it inside the scanner. And what is cool about this method is that it's non-destructive.
Yeah, this technology is the computed tomography scanner that works the same as the CT scanner we know for the medical use.
It's the same technology. We only need to have a greater power that normally could be dangerous for patients. But for rocks, it's not a problem. Here, we tried to use the difference between the density of the fossil and the density of the surrounding rock.
CT scanner gives the researcher a 3D visualization of Belartia skeleton. It then reveals a more reliable example of primitive squamate which already extinct.
Thanks to Belartia, we know that this was an extinct lineage of lizards that was living together with modern types of lizards, but for some reasons it didn't survive to modern times. So probably there were many more extinct.
This skeleton of primitive lizard shows us some traits related to modern squamates. These Bilharziia fossils show us the last stage of evolutions exactly before the modern squamate morphology appeared on Earth. But then, why is this morphological evolutions that happen in Bilharziia doesn't last long? And what ecosystem change that triggered the transformations from primitive lizard into modern-looking lizard that we are now used to see? That's the next mystery that needs to be explored.
Part of my job is to study how ecosystems react to various environmental changes in the past. So with that knowledge, we could better prepare ourselves and our legislature towards protection of modern ecosystems, and we could better predict what will happen in the future.